Everyone, I'm Emily, and this week we're going to work on understanding the concept of hybridization. The question is asking us to explain why methane, CH4, has a tetrahedral geometry. And it's giving us a hint telling us to start with the electron configuration of carbon. So if we do the electron configuration for carbon, we have our 1s2, 2s2, 2p2. And if we were to draw the diagram for this, this is increasing energy. We have our 1s orbital down here, the 2s orbital is in a higher energy, and the 2p orbital is in an even higher energy. We have 2 electrons in the 1s, 2 in the 2s, and 2 in the 2p. Now, based on this, we would think that carbon would form not equivalent bonds because its valence electrons are in different energies. They have different energies. Thus, they should form different bonds and not equivalent bonds. But we know that that's not the case. Based on the evidence that is out there, the data that's out there, we know that carbon forms four equivalent bonds and has a tetrahedral geometry. So in order to explain that observation, we utilize the concept of hybridization. And what we end up doing, this 1s is going to stay where it is with its 2 electrons. But we form 4 hybrid orbitals, and each one of them is going to be an sp3 because it is 1 part s and 3 part p. And the 4 electrons, the 2 in the 2s and 2 from the 2p, fill up these hybrid orbitals. And now we see that the 4 valence electrons are all energetically equivalent, and thus we should form 4 equivalent bonds, which is the case with carbon. For example, in the case of methane, we have 4 equivalent electron clouds, and 4 equivalent valence electrons, so they form equivalent bonds. And thus, the geometry is tetrahedral, because that's how these electron domains are going to spread from each other as far apart as possible. Okay. I hope this made sense. If you still have questions, feel free to come to office hours or attend the session on Wednesdays.